Dr. Radha Subramaniam. Today we are going to learn a short trick for SN2 reaction. Okay, already I have uploaded the mechanism for SN1 reaction in my previous video. So today let us see about SN2 reaction. So what is SN2 reaction first of all? SN2 reaction is a nucleophilic substitution reaction. So what happens in this reaction here? A bond is broken and another bond is formed synchronously. So here it involves substitution reaction of a leaving group with a nucleophile, very simple. So when I explain the mechanism of this reaction, you will follow this reaction easily. So what does SN2 stand for? So it is substitution, nucleophilic substitution, and it is a bimolecular substitution reaction. Okay, let us see what is happening here first. See, carbon is attached to 4 different groups here, okay, and let us think that a strong nucleophile is attacking. So this is sp3 hybridized tetrahedral structure. Now transition stage will be formed first. See here, what happens is that when a nucleophile attacks, it gets attached to this carbon atom through a weak bond. At the same time, X is also linked with a weak bond to the carbon atom. Okay, so nucleophile comes and gets attached to the carbon atom. At the same time, the halide group is also here, which is attached to the carbon atom through a weak bond. Fine. Now see how many bonds are there around carbon atom. We can see carbon has 5 bonds. Okay, so nucleophilic bonds become strong here. So this is trigonal bipyramidal shape, and the bond, it's not formed completely. So it is sp2 hybridized and it's unstable. And what happens in the next step? It's partially negative. Okay, the halide group will leave this structure. Okay, and finally you get like Nu, this carbon is attached to R, then D. HX will leave the group. Okay, now this is the mechanism of the reaction. Hope you followed this. Now let us see the trick over here. See, alkyl halide, as you know, there are 3 types: primary, secondary and tertiary. See, if carbon atom is attached to 3 different, this is methyl group and carbon atoms, so this is called tertiary. Okay, and here if it is attached to 2 carbon atoms, it is secondary, and only one is there, means it is primary. Okay, see, in this case the nucleophile can easily attack the carbon atom over here, but tertiary alkyl halide cannot get involved in SN2 reaction. Why? Because see, it is fully, nucleophile cannot easily approach the carbon atom because more groups are there. So due to the presence of less number of groups for primary, the nucleophile can easily attack here in the case of primary. Okay, so here see, this is tertiary, secondary, primary, that is the order of the stability. More stable is tertiary and less stable is primary. So here in this case SN1 reaction is favored, but you see for SN2 reaction the order is primary, secondary and tertiary. Okay, and the nature of the solvent will be, see, polar proiotic. I taught you about for SN1 it is polar proiotic. I taught you about all these concepts in the previous video. So those who haven't watched that can go back and watch the reaction. See, the SN2 reaction mechanism, it involves nucleophilic substitution reaction of the leaving group, okay, with a nucleophile in a given organic compound. So here SN2 mechanism, just remember, it always requires the attack of nucleophile from the back side of the carbon atom. Okay, so the product assumes a stereochemical position opposite to the leaving group, and SN2 reaction, it's a good example of stereospecific reaction. What is that? One in which different stereoisomers react to give different stereoisomers of the product. Okay, so here again let us recap it once again. SN2 reaction, it's a nucleophilic substitution reaction where one bond is broken and another is formed synchronously, and 2 reacting species are involved in the rate determining step of the reaction, and SN2 term stands for substitution nucleophilic bimolar, and we also call this type of reaction as bimolar nucleophilic substitution or associative substitution, interchange mechanism and all that. Okay. And normally strong anionic nucleophiles will speed up the rate of the reaction, and nucleophilicity will increase with a more negative charge, and a strong nucleophile can easily form a carbon nucleophile bond. Okay. And polar aprotic solvents, they do not hinder the nucleophile, but polar solvents form hydrogen bonds with nucleophile, and you can say like acetone is a good solvent for this reaction. And stability of the anion of the leaving group and weak bond strength of the leaving group bond with carbon, it helps the increase of the rate of SN2 reaction. Okay. And as you all know, SN2 reaction is a second order reaction. The rate determining step is dependent on the concentration of the nucleophile as well as concentration of the substrate. Okay. And always, as I mentioned in the last class, there are two ways in which the nucleophile can attack the stereo center of the substrate, that I explained in the last class itself. That is, one is front side attack, where the nucleophile attacks from the same side where the leaving group is also present, and also back side attack is the nucleophile attacks the stereo center from the opposite side of the carbon leaving group bond, that results in the inversion of the configuration in the product. Okay. So, purely SN2 reaction, it shows 100% inversion in stereochemical configuration. So, it is clear that the reaction will happen through a backside attack. Okay. So, nucleophile will what do? They will displace the leaving group in given substrate, and we can note that primary and secondary substrate can take part in SN2 reaction where tertiary substrate cannot. Okay. So, this part of the reaction mechanism is very important in organic chemistry. So, I think that I have tried to explain this concept in a very simple way for you, like both SN1 and SN2 reaction mechanism, and you have to go through this concept well, and you can also take a rough note and try to write the structure for your easy understanding. If you write it and learn, you will never forget it. Okay, just by reading it, that won't be retained in your memory. So, all of you just warm up and speed up your revisions and all that. You see, just only a few weeks of time for your Neet exam. So, also we will be uploading many videos. So, many students are requesting videos from different topics and all that. I will try to include maximum portions before your exams, and I am just very happy again to note that many subscribers are joining this channel every day. So, I am so happy to see that, and my prayers are all with you for you to do the exams well and crack the Neet exam. So, do kindly share, like and subscribe to our channel Chemistry Made Simple for Neet, and thanks for watching.